Next, we're going to go ahead and take a look at system of equation word problems, and we're going to follow a process similar to what we do with linear equations. We're going to select variables to represent unknown quantities if they're not given to us. We're going to use the given information to write a system relating the two variables, and then we will solve the system using whichever method we prefer, substitution or elimination, or even graphing if we needed to. So we have a theater production that charges $21 for adult ticket and $15 for student tickets. If the production sold 102 tickets for its opening night and they made $1,932 in ticket sales, how many of each type of ticket were sold? How many of each type tells us what we're solving for, which tells us we need variables to define them. There are two types of tickets. There are adult tickets and there are student tickets. What variable you use does not matter, but it's helpful to identify them. If you use something like X and Y, make sure you note which one is which, because they may ask for specifically the student tickets or the adult tickets, and so you'll want to solve for that specific value. So we have to think about the scenario that we have here, and we want to try to model it. Well, we're selling tickets. So the number of adult tickets and the number of student tickets has to be the same as total tickets sold. And so we can say that, well, if A represents an adult ticket and S represents a student ticket, it has to equal the total number of tickets sold, which was 102. So we have our first equation, A plus S equals 102. Next, if the adult tickets, so cost per adult ticket, and the cost per student ticket has to be the same as the total revenue earned. So if it's $21 per adult ticket and $15 per student ticket, it has to equal the $1,392, and now we have our second equation. 21A plus 15S equals 1,932. So now we can go ahead and actually solve our equation. I'm going to use elimination method, but you can use whatever method you want to find your solution. So once we solve for A and S, we know that we have 67 adult tickets and 35 student tickets. Next, we have a player of a trivia game receiving 100 points for each correct answer and loses 25 points for each incorrect answer. Leona answered a total of 30 questions and scored 2,125 points. We want to write an equation that relates the total number of questions answered C to the number of questions she answered correctly, number of questions she answered correctly to the number of questions she answered incorrectly. So right there what they've done is they've defined our variables. C represents correctly answered questions, and I represents incorrectly answered questions. Now, if we take the number of correct and the number of incorrect, it has to be the same as total number of questions. So that gives us our first equation, is that correct questions plus incorrect questions has to equal the total number of questions, and the total number of questions was 30. So our first equation, C plus I equals 30. Second equation is we know that you get 100 points for every correct question, but you lose 25 points for every incorrect question. So 100 points for every correct question, but we lose 25 points for every incorrect question. And that difference has to make up the total number of points. Okay, so points per correct and lose 25 points per incorrect to equal total score. So 100C minus 25I equals 2,125. Now, you can again solve this with any method that you like if we need to solve it. But here, we just need to write an equation that relates the total. And so here is our system represented. Okay? We don't need to solve anything because the question didn't ask for it. We just need to make sure we could write the equation. So here's a multiple choice one for us. At Beans and Bagel, a bagel costs $1 more than a cup of coffee. If 4 cups of coffee and 6 bagels cost 31, which of the following system's equations can be used to determine the price of the bagel and the price of a cup of coffee? So let's really think about it. So a bagel costs 1 more than a cup of coffee. So let's think about and look at the equation that represents that a bagel is 1 more than a cup of coffee. Okay? So we kind of want to look at our equations and see if we can find that represented anywhere. Well, this equation says that coffee minus $1 is a bagel. So a bagel is actually cheaper than a cup of coffee, and that's not going to work for us, so we can eliminate that one. Here we have coffee plus $1 equals bagel, so that could be one of our options. So that's a possibility. Again, this one is decreasing the price of coffee, so that's not going to match it. And then we have, again, the addition. So either of these could be our answer. 4 cups of coffee and 6 bagels cost $31. So we have 4 coffee, and 6 bagels cost $31. Well, this one has 4 bagels and 6 coffees, so that's not going to be it. This one has 6 bagels and 4 coffees. That is going to be our solution. Last question on our systems. A group of 41 people are going to a concert together in 7 vehicles. Some of the vehicles can hold 7 people each, and the rest can hold 5 people each. Assuming all the vehicles are filled to capacity, exactly how many vehicles can hold 7 people? And so let's just say we have cars and vans. Cars can hold 5 people. Vans can hold 7 people. So we know that cars and vans has to be 7. So car C plus V equals 7. And then we know that since cars can hold 5 people, it's 5 people per car, plus the 7 people per van will equal the 41 people that are going. And now we have a very basic system. We just want to find how many vehicles can hold 7 people. That means we only need to solve for V. And if we only need to solve for V, what we want to do is eliminate C. So the way to eliminate C is to use either substitution or elimination. I'll do substitution to figure out what C equals. C equals 7 minus V. So that way when I substitute it in for here, I'm left with an equation that does not have C in it, it only has V. So now I can go ahead and solve. 35 minus 5V plus 7V equals 41. And then we can combine like terms. we need exactly 3 vehicles that can hold 7 people.